So, in order to demonstrate this issue, I'm going to do a little experiment that I've done for 30 years in my philosophy class. It's the same experiment that Socrates does in a dialogue called the Meno. And in the Meno, we talk to a slave boy. Let's call him Bob. He's not given a name, and it's probably not Bob, but in the dialogue, Socrates gives this slave boy a little puzzle. Now, we know that he hasn't had any background in geometry, and, frankly, my students haven't either. I mean, supposedly they took a class in geometry in high school, I don't know, and paid no attention. Nevertheless, they've probably never seen this problem before. And I give it to them every year, done it every year, and several times a year. The result is always the same. It's important for an experiment to be repeatable, and this is a repeatable experiment. This is an empirical research project. It's not like most philosophy. This is an actual science experiment, and I'm surprised it hasn't been done more thoroughly throughout the world as an anthropology experiment. But nevertheless, let's just do the experiment now and see what we come up with. I must say that I must have read this 20 times without thinking anything of it. It's just some dumb little problem. But let's see what's mysterious about it. We're going to take a square. We're going to tell Bob, Bob, we want to make this square twice the size as it is. So what are we going to do? How do we do that? And if you're like Bob, you probably say, well, first guess is let's just double the sides. But, okay, let's try that. But if you double the size, look what you get. I mean, it's actually 4 times the size. It's not 2 times the size. We're looking for a square that's 2 times the size. That's not going to do. So let's try, I don't know, 1.5 times the size. That may work. So let's bring this out like that, and like this, and like this. And is that twice the size in area? Well, no, it isn't, actually. I can prove it's not, but let's not do that. That isn't the right answer either. How can we come up with this? Well, I mean, if you're a math guy, you would use the square root of 2, but that's really not what we're trying to do here. We're going to try to do this as a geometry puzzle, not an arithmetic or an algebra puzzle. So now we'll scratch our heads about this, the class will, for a while, and finally somebody's going to say, well, what if we do this? What if we make a diagonal? And then on the diagonal, we create another square with that as the side of the diagonal. So now we have a square. Here, these 2 parts of the square are equal, but instead of having 2, we have 4. So this is exactly twice the size of the original square. That's the solution. Okay, so everybody says, wow, I didn't think of that, but here's the weird thing. First of all, we're going to take the students at their word that they've never seen this problem before, and somebody just came up with it. But something else mysterious happened, and that is, when the solution was presented, everybody in the class instantly recognized that it was the right solution. Now, that may not strike you as peculiar, but compare it to other kinds of information that somebody could have provided the right answer to. Like, let's say the question was not about geometry. It was about, the capital of Arkansas. And people said, maybe it's Little Rock. No, I don't think so. I think it's Des Moines. No, that's not. And somebody would guess. And finally, we'd agree it's Little Rock. And 3 or 4 people would say, yeah, that's right, it's Little Rock. Other people would not be so sure. Maybe that's it. I don't know. I don't remember. It's a different kind of recollection. It's something that you've learned before and been taught before. Let's take another example for comparison. Instead of saying, let's have a square that's twice the size, let's say we want a circle that's twice the size. Well, is that circle twice the size? It's not a very well drawn one, but let's just say, is that twice the size? I don't know. We just kind of have to eyeball it, don't we, to see if it's twice the size. We'd be guessing. There's not any certainty. Whereas with the square business, we had absolute certainty. That was going to be exactly, not even a millimeter off, not even a millionth of a millimeter off. That was going to be exactly twice the size of the first one. Now, you may notice I drew it. When I drew it, I didn't try to draw it carefully. I could have created this on a computer like Illustrator, and I could have given you a perfect, or as far as a computer can make something perfect, a perfect example of this. But I didn't do that because when you saw that this was twice the size of the first square, you weren't recognizing it with your eyes. You weren't recognizing it because you could visually compare one to the other. The information was logical space, the space of these two geometrical figures related to each other in a certain way that you immediately saw the truth of.